I would like to stress some points of advantages of real-time processing comparing to the swept analyzers that we talked before. First, in the process of digitalization of the analog signal, it is possible to correct the imperfections of the analog signals in real time, because this is not very easy to do in swept. This is because of the concept that we show that processes are signals and frequencies are overlapped on each other. So this gives the advantages of making the corrections of the imperfections in the process of digitalizing the analog signals into digital signals. Okay, signals that cannot be observed on swept type analyzer can be easily captured, and this is of course the result of the concept of the FFT overlap that we talked when we showed the concept of real-time analyzing. And signals that are masking other signals can be displayed. This is not totally not possible on swept, and we will see it on next example that we'll see in the following video. And the modulations is another issue, that we can demodulate signals. This is also a result of the concept of the parallel FFT frames, superposition of the frames, and which are enabling the process of the modulations in the processor. So let's see some videos that shows more intuitively and in real cases the advantages of the real-time processing. Okay, so let's see a comparison of a pulsed signal between two views, swept and real-time. It's pulsed 4.6 millisecond between each pulse. So let's see how it works. So here's the signal. No specific pattern can be seen here. Okay, and we'll stop it and move to the real-time. So you can see it is really hard to understand exactly what's going on here. And we move to the real time here. And here you can see a clear pattern of the signal, which a fixed distance between pulses. So this is basically the difference between the two views, and it's really significant. So let's see another example, this time in the frequency of 2.4 gigahertz, which is both Bluetooth and Wi-Fi are using. And let's see what will be the difference in view between swept and real-time mode. Here we can see a swept mode, and the blue pattern, the blue line is the maximum hold, max hold, also known in most of the equipment. It's the maximum amplitude that a signal can reach in every frequency. So it draws a line. So here we see in swept mode, and we can see that these lines are basically the Wi-Fi and the Bluetooth, but we cannot differentiate very much between them. And then we'll see how we can display it in a real-time mode. Okay, so we have here, by the way, we have a span of 40 megahertz, and each 4 milliseconds there is a screen refresh. Okay, so it takes 40 milliseconds for the next display of 40 megahertz, and in this transfer when we can lose signals in swept mode. Okay, let's see how it is can be shown in a real-time mode. And here we are in the real-time mode. Okay, so you can clearly see the Bluetooth changing channels. Okay, this is a better view. And also you can see the Wi-Fi also. So this is a view which is totally not possible on a swept mode. So we'll move to the waterfall also, and you can see the characteristic of the pulse on the sides and in the middle where it's imposed on for the two signals. So this is another view which can add more information on the signals. So this is another example of distinguishing between Wi-Fi and Bluetooth, this time with Fielfox, which is the equipment that I'm using of Keysight, the manufacturer. So you can see here the distinguishing between the Bluetooth and the Wi-Fi, which is 2.4 gigahertz in this case. Let's see how it shows here. Okay, you can see it here on the right, the spectrum analysis on a swept mode. Let's see it better here. This is the Bluetooth. And you can clearly see also the Wi-Fi signal as well. This is the advantage of the RTSA feature or technology.